Hello everybody and welcome back to SkySaga Alpha 9. We're over here on the tutorial island. It is time for another tutorial Tuesday. So today we're going to be looking at comparators. Now these are a way of comparing two signals to make sure that they are exactly the same. So a good little example of what that does is behind me. So right behind me I've got a little bit of a combination lock. So as you can see up on the wall over there, two of the red lights are lit and one of the red lights is off, and then my side is hooked up to the orange light. So if I go down here, each of these pressure plates turns one of those on or off depending on what I do. So as you can see right now, this orange light is on and that red light is off. And then if we go ahead and turn on the other two orange lights, you will see that the door does not open, as you can see, because I've got all three of mine and the top two are on and the third one is off. So if I then turn this guy off, you'll see that the door now opens. So this is what a comparator circuit does. I've actually got three comparator circuits hooked up, all ANDed together to open and close that door. So if I now go back here and turn this guy on again, you'll see that the door comes back because now the signals aren't equal, and we can turn a couple of these guys off just like that. And then the reason I've got this set up and the reason I'm running this through a comparator is now I can go all the way out the back here where I've got a very similar setup, and I can actually change the signal that I want to have activate the door. So now the door is activated by three lights on, so if we walk all the way across all of these, that'll turn all three lights on and the door will open just like that. So this circuit is actually not too complicated. It does take a few blocks, and then of course you can stack them together to do what I've done here. So if we have a quick look behind the wall, there is three comparators here and then two AND gates to link those together to actually get the door to close. So let's take a quick look at how you do this. Now over here I've got two inputs. I've got my A side input and my B side input just here, and these are hooked up to the same pressure plate and latch system that I had before. So the closest pressure plate turns the latch and the light on, the furthest pressure plate turns the latch and the light off. So now to make a comparator that sits between these two things, all we need is two AND gates, three NOT gates, and an output of some kind. So we're actually going to start by putting down our NOT gates. That's going to be the first step. So the first step, what we want is we want the two NOT gates, and I'm going to go all the way out on either edge just like this. So that is the two NOT gates there. Then we want two AND gates, just one in from each of those, and then of course we want the final gate up like this. So now we've got a little kind of like pyramid shape going on, and I think we'll just wait for daytime. So now that it's daytime, we're going to do up the connection system here. So as I said before, we have an A input and a B input. So we're going to run each input into a NOT gate. So both A and B go into a NOT gate, and they go into the NOT gate on their own side. Now the NOT gate goes into the B side of the closest AND gate, like that, 1 and 2. So both of those go in like that, and you should see you've only got things connected on each side right now. And then the next thing we're going to do is we're going to take the inputs and cross them into the other side AND gate. So the A side input goes into the AND gate over on the B side, and we're actually going to put that into the A side. And then we're going to do the same with the B. So the B input crosses over to the A side AND gate, and it goes into the A as well. So you should get this nice little crisscross pattern happening in your Lumo stone lines, just like I've got there. Now once we've got those two things done, both of the AND gates go into the furthest NOT gate, just like that, and then all of that stuff goes into the output. So the final NOT gate goes into the output. Now as you can see, when I first link this thing up, this output is going to be on because both lights are off right now. So if we go down here and turn one of these lights on, what you'll see is this light turns on, that one is off. They're not the same, so the comparator turns off and the output is now off. But if we then of course go over here, turn this other light on, then you'll see that because both lights are now on, the comparator is on and the lamp turns on. So once again, we can go over here, we can turn one of these lights off, and we'll see that the comparator turns off. And if we turn both of them off, then the comparator goes back on again, just like that. So Then all you need to do to link that system across from one system up to 3 systems, 4 systems, 5 systems, whatever you like, all you need is you link your comparator output rather than into the output directly. You take your comparator outputs and stack them into AND gates. So for 3, you want to take 2 of your comparators and run them into one AND gate, and then you want to take your other comparator and take that into a second AND gate, and then run the first AND gate into the second, and then take your output from the second all the way out to your actual output over here. So once again, this thing is still working. It's just that when circuits reset and you connect a new LUMO line to any circuit, all latches default to being off. So if I go up here and click this, you can see that all of the latches defaulted to being off, so both circuits were exactly the same, and that door opened up. So this is not perfect. In fact, if you're going to do a puzzle island, it would probably be best to set an actual code that you want to do. Just hard code that in using NOT gates in the back out here and have it run that way. However, we've done it this way because this is a lot more powerful, and then when we go ahead and next week talk about other kind of interesting little systems where we can change this input as the user does things, we're going to be able to have a lot more power out of this system, because this system, regardless of what the top line says, the user copies that into the bottom line, then everything works. Also, obviously, if you're going through and doing this as a actual puzzle mechanism, you would want to set your latches up a lot different to this. This is a very, very simple system, and it's very easy to break this puzzle because it's literally just copying the lights. Whereas I personally would link up the pressure plates in a different way, so that when you stand on pressure plates, some latches turn on and some latches turn off, and that way it becomes more of a puzzle to work out exactly which plates you press in which order to get the combination that you need to open the door. But anyway, that's just kind of the nuance for this thing. The actual circuit itself is not too hard. It is just the 5 gates and a few kind of connections between all of those. So I hope you guys have enjoyed that one. I hope I see some interesting puzzles come out of people using this, and I will see you in the next episode.